The syntax for creating multi-statement functions can be more complex than the syntax for scalar or inline functions. And this shows the general form of that syntax. So you again use the create function. You can create different parameters. But in this case, you need to specify the shape of the table that's returned. So you actually have to define the columns in the table as though you were creating a persistent table within the database. And then you can use the with clause with different function options. And then the as clause contains the body of the statement. Because you can have multiple statements within the body, you have to have the begin and end. But because you have to define the structure of the table, in order to end the function and return the table to the calling code, you just use the return statement. So it's just some basic variations on the scalar function and inline function syntax. Now, unlike inline functions, the result sets that multi-statement functions return are always read-only. They can't be used to update data. In fact, there's only a few actions that are allowed within the code body of the function. You can do normal Transact SQL programming operations, such as declaring and assigning variable values and creating control of flow logic. Select statements that contain select lists with expressions that assign values to variables that are local to the function. You can also use local cursors that are declared, open, closed, and deallocated within the function in their entirety. So in other words, you can't create a cursor that is then used outside the scope of the function. And specifically, you can't use fetch statements that return data to the client. And then you can include insert, update, and delete statements that operate on table variables local to the function. But you can't modify external tables. And then execute statements that call extended stored procedures only. You can't invoke either user-defined or system-stored procedures from your function. So multi-statement functions are much more limited than stored procedures because you can't use them to modify data. But the capability to select from the table that is returned makes these kinds of functions a better choice than stored procedures for returning complex result sets where you have to write code in order to generate the data. Now let me talk a little bit more about the table data type. The table data type allows you to use a table variable within your function. You can use the table variable much the same as you do temporary tables and stored procedures. And the action of a multi-statement function centers around building up the table variable, which is then used as a return value for the function. Temp tables aren't allowed in multi-statement functions. Instead, you can use a variable with a table data type. And unlike temporary tables, the table type variables are not stored in TempDB. Table type variables are in memory only. And they have the added advantage that they can also be used in triggers where temp tables also are not allowed. So let's take a look at creating a multi-statement function. There's various ways that you can use multi-statement functions. For example, you can rewrite stored procedures that enforce logic and retrieve data as multi-statement functions. Inline functions like views can only select data in a single statement. So if you want to control the flow of execution or apply conditional logic, then you need to use a multi-statement function, and that's what this example does. So what this order by employee country function is going to do is it allows dynamic querying in which you can specify any number of input parameters or none. So you can provide a value either for employee ID or for ship country, or both of them, in order to search the Northwind orders table. This function is a little bit more complex than others because I wanted to be able to show you how you can use conditional logic within the body of the function in order to return different kinds of result sets in response to specific combinations of parameter values. So I'll break it all down into sections. All right, so the first section is the create function statement. So this defines, as usual, user-defined function with that name. It can be in the DBO schema. And it defines a couple of parameters, both of which have default values of none. And then the next part of the function sets up the returns value. For this kind of function, I have to declare a table variable. So in this case, I'm going to call it order, and it's of type table. But I have to go one step further and define the schema for the table. So just like using the create table statement, I need to define the different columns in the table and their data type. And if I want, specify whether they allow nulls or not nulls. So in this case, all of the columns require values. And I have a ship country with an varchar 15, a customer ID nchar 5, order ID int, and an employee ID int. Okay, so that's the structure of the table that this function is going to return. All right, so now it's time for the body of this function, and that's defined within this as clause. So the way the body has to work is that everything has to be within this begin and end keywords, within that as clause. And the return statement has to be the last statement before the end. So that's what I have right there. And so what we're doing here is that this function is going to return a table that's filtered depending on the values of the input parameters. If both employee ID and ship country are null, then it returns all of the rows from the orders table. And it's that logic right here. So if employee ID is null and ship country is null, it just goes ahead and executes this statement. Remember that this is the table variable, so I'm using a select clause in order to read data from the orders table and insert them into order. So this is all a single statement. All right, the next piece handles a situation where employee ID is null, but ship country is not null. So in other words, I'm supplying a value for ship country, but not employee ID. So once again, I have a single statement. I can have multiple statements here if it makes sense for the logic, but in this case, I'm just inserting some rows into that in-memory table. And now I'm selecting from orders, but I'm filtering on ship country. All right, then the next chunk is right here, and this handles the case where I provide a value for employee ID, but not for ship country. In this case, now I'm going to filter by employee ID. Once again, execute a single statement that inserts row into that order table from orders and filter on that employee ID. And then the last case is if employee ID is not null and ship country is not null, or in other words, I supply values for both of the parameters, then I'm going to filter on both the ship country and the employee ID using the same sort of statement. But now my where clause has gotten a little bit more complex because I have to filter on both conditions. All right, so at this point, I've run the gauntlet of all the possible combinations of values for employee ID and ship country. My order table theoretically has data in it. Maybe an empty result set, but it at least has the structure of it. And so I just execute return, and it knows to return the tables defined within order because I defined that right here. Okay, so a little bit more complex an example. I'll go ahead and select this all and press F5 to execute it, and now it exists within the Northwind database. Now, before I look at executing the code, there's one other thing I want to talk about. Before I look at executing that code, I need to bring up a topic. Because there was a breaking change in the behavior of multi-statement functions in SQL Server 2012. In earlier versions of SQL Server that supported this function type, you could include an order by clause in the select statement that populates the table variable and that would be the default sort order for the data returned by the function. This is because the execution plan included a sort operator to support row count semantics. And it uses the same plan, or used the same plan, whether row count was used within the code or not. So don't worry too much about the details of row count. But the important thing is that that particular behavior, returning the rows in that specific order, was not guaranteed. But it worked that way, so a lot of people relied upon it, and unfortunately I was one of them. So the change is that for efficiency, SQL Server 2012 now creates different plans for the two cases. And so, when row count is not used, the data is not sorted. So that changes the behavior. And because most often you're probably not going to use row count, that changed the behavior for probably the most common scenario in which you use this kind of function. Now, there are various workarounds available, but the best option is to follow the lead of the sample code that I'm using here and treat the data returned by the function as unsorted, just like a normal table that doesn't have a clustered index. And then you include an order by clause in the statement that invokes the function, because that's really where sorting should occur. It makes the behavior of these functions more similar to just querying the data of a table directly. Now let's take a look at executing this multi-statement function. You use the same syntax to execute multi-statement functions as for inline functions. So you select columns from the function because it returns a table, and you can also include an order by clause. Okay, so here's one example where I'm explicitly setting two variables to null. And then I'm passing those variables as the parameters to that multi-statement function. And because I'm not supplying a value for either of those parameters, when I execute that, I get 830 rows back. It's all of the rows within that order details table. Or I can filter on employee. So here, rather than using separate variables, I'm just using explicit values that I'm passing as parameters. So this is going to be employee ID 6. And when I select from that, now I get 67 rows because that particular employee had 67 ordered detail items. Now, just like a table, you can rearrange column and sort orders. So in this case, I'm passing a value for country, for the ship country, but a null for employee ID, but I'm only retrieving a subset of columns. So again, you can treat this just like a persisted table, and I can order the data in specific ways. And I'll execute that, and now we have 23 rows that shipped to Spain. You can also use SQL Server keywords within the query. And I just include this to show that this really is just like a regular select statement from a table. So if I wanted just the distinct countries, then I could execute this. It's the distinct countries that were orders by employee ID 6. I'll execute that, and now I have a list of all the countries that that employee was involved in orders with. All right, then one other nifty thing you can do is, again, because this is a table being returned by this function, you can join to that function as well. So here I'm getting the list of orders, and specifically the ones shipped to Italy, and then I'm joining on the employees table so that I can display the last name and first name of the employee that was involved in the sale. And when I execute that, now I have the last name and first name, the customer ID, and the order ID, again for all of the sales to Italy.